Hello there. This is my little short video that details all about linear functions. I'm hoping that we can go through almost the entire topic through one little video, basically. So let's start at the beginning, because the key thing that we need to know about is Cartesian coordinates. Once we know that, we will be able to do the rest fairly easily. But when we say Cartesian coordinates, we're talking essentially about a way to talk about space in two dimensions, as in on a flat surface like this. So we could have, for example, something like this. This is a very common sort of thing. Cartesian coordinates specifically constitute of an x, which is horizontal, and a y that is vertical. Okay, cool. So all of this comes together with the idea that what if we start putting numbers on each of these? Because then you could have this point here, the middle, where the two axes cross. Where they cross, we will call this the origin. And then after that, then we can start putting numbers. So for example, this could be 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. And of course, down here, characteristically, this would be -1, -2, -1, -2. Through this, we can begin to identify all kinds of points on this system. For example, if I were to go ahead and I were to put a point here, I could say, okay, so how do I explain where this point is? Well, it's 1, 2, 3, 4 on the x, and it is 1, 2, probably about maybe 2.5 on the y. I'm going to call it 2 here. So what that means here is that basically I can say that this has a coordinate. Remember that word? The coordinate of 1, 2, 3, 4 on the x. X always comes first whenever we're talking about coordinates. They tend to look like this. And then the y, 2. We could do the same over here at this point here. This would be, for example, -1 and then 1 for the y, because we are 1 up. That is basically the gist of what we talk about when we say coordinates. So, now we know our coordinates. We're going to move into some other points, because this is ideally something that you already know a little bit of, or at the very least isn't so difficult to understand, that we can have an x-axis and a y-axis, and we can use that to describe any kind of point we want. Once we know that, we can move on to talking about straight lines in 2D space, because that's what we're really interested in. We're interested in talking about lines in a two-dimensional space. So, what kinds of things do we need to have for two lines? Well, let me once again draw a nice set of Cartesian coordinates. For the sake of ease of use, I'm just going to keep it all positive. If we go ahead and if we draw a line somewhere in this space, like for example, a line that looks like this, something that we need to describe this line, there's a few different ways. One way is that we could say, well, it passes through these 2 points. There's no other way to create any other kind of line, or at least any other kind of straight line, that passes through those 2 points. If we try, we could try and make a different kind of line, one that's not like this. Maybe that would be like this, but then it would be impossible to ever touch this point if we went like this. This is never going to go through this other point. The only way to get it to go through both is for it to have this exact shape. So we can say a line needs 2 points, or else we don't know how to make it. Okay, you can do it with 3 or more, of course, but 2, you absolutely need at least 2. So we should probably write that, actually. At least 2 points. Okay, so we have our 2 points, and from that we can create a line. The thing about that is, 2 points, each point would have its own coordinate, and thereby we would have an xy here and an xy here. That would require 4 points. That would require 4 numbers to talk about one line. I want to do it with fewer numbers than that. So what am I going to do? I'm going to introduce 2 ideas. One idea is going to be slope, and one idea is going to be y-intercept. So, let's describe each of these in turn. I think I'll use red to talk about the y-intercept, and I think I will use yellow to talk a little bit about slope. So each of these has their own understanding, and we will come back to them and see other understandings too. But if we start with the basic one, a y-intercept simply means if we look at this coordinate system, all we need to do is look at this line and see when does it cross the y-axis. It crosses here at this particular point. This particular point should have its own y-coordinate. It should have its own y. Obviously the x will be 0 because that's what we decided that this point down here is, 0 on both. So from that we can say, well, this looks like it must be maybe 1, 2, 3, 4, 5 or something like that. Could be. Depends a little bit on what the scale is here, but let's just say 5 today. So fundamentally we can say, okay, this has a y-intercept and it's something positive, maybe 5. Y-intercept, all that means is when does this cross this particular line? What about slope? What's slope? Slope has to do with how is the line going? Because we can imagine multiple lines that pass through this point. We could imagine a line that passes through like this. This is clearly a different line than this blue one. We could also imagine a line that passes through like this, also different. All of these different lines have different slopes, as in how much are they slanted, upwards or downwards. In our case, our blue line is slanted slightly downward. How are we going to describe how much it's slanted downward? With a number. So, the number we're going to use to describe how much it's slanted with is slope. In our case, the way that I would suggest that we do it at first is say, let's move 1 on the x and see how much I need to adjust on the y to make it work. In this case, it looks to me that I need to move down maybe half as much as I need to move across. Therefore, I would say that this number here, minus 0.5, because I have had to move down a half, down, hence the minus, a half, hence the 1/2, I would say here that my slope for this blue line is probably minus a half. So from that, I can say that for this specific example, I have a y-intercept 5 and a slope of minus 0.5. Let's talk a little bit about how we would define these. I'm going to say slope is if you move 1 in x, how much in y? For the y-intercept, I'm going to say, when do we cross the y-axis? And that's actually it. That's actually it, really. But both of these I have defined a little bit loosely right here. These both, they all work, don't get me wrong. You can work with these definitions. But I want to offer a more formal walkthrough now. So all of this I will wipe out, and then I'll show the formal walkthrough, and that'll be it for this video. So let me go ahead and wipe things down a little bit. Once again, we'll go ahead, we'll make a nice XY diagram so that I can put in 2 points. I think I'll pick yellow. I'll put a point right here, and I'll put another point right here. We want to talk about this straight line that goes between them. So, how are we going to talk about that line? Well, first we're going to say what these 2 points are. I'm going to say this point here looks to me like it might be, maybe this is 2 and 2. Then we would continue, 3, 4, 5, 6 for this one, as its x, and then as its y. Let's see, 1, 2, 3, 4, 5, maybe 5. We now have 2 coordinates. And really, that's enough for us to sketch the straight line, but it's not enough for us to actually talk about what the straight line is using slope and y-intercept. Now we're going to show how to do that. For that, we're going to use a formula. We can get slope by doing y2 minus y1, x2 minus x1. When I talk about this one, notice how I'm saying x2, y2, x2, x1. The reason I'm doing that is because each of these two coordinates has an x, but they also have a y. I could call this maybe my second point. Then this will be my x2, and this will be my y2. This would then be my first point, and I can call this my x1, and this can be my y1. Now, in my formula, I can go ahead and insert all that information, and I can get that I would have y2, that's 5, minus my y1, that's 2, divided by my x2, 6, minus my x1, 2. In turn, I will eventually get 3 over 4. My slope for this line is 3 divided by 4. Okay, I have the slope now. This is a very, very accurate way of getting slope. The problem is I still don't know my y-intercept. Here we're going to use something that I call the function notation, or straight line notation, really. Because a lot of the time, when we're talking about a straight line, we will often put it in this form. In this form, we have y equals to the slope. I'm going to call it a here. So perhaps I should write a little line that says this is slope. And then here, my y-intercept. A, the slope, times x plus the y-intercept. Now you may be wondering, how can this possibly help us? Well, we know the slope now. We do know an x and a y here, and we know an x and a y here. This should be true for any x and y pair that falls somewhere on this line. So if we knew this point, or this point, or this point, they should all work in this formula. Let's try it out with what we know. Now, I don't have an awful lot of space on my board, but I will have to make do. So let's go ahead and let's just move things a little here. I'm going to have to adjust a bit on the fly. And I'm going to try and do it over in the corner. So that's over here. Here, what we'll do is we'll go ahead and set it up. I'm going to pick these ones 2 and 2. I'm going to pick them because I think they seem the easiest. So I have 2, that's my y, equals to my slope, 3 divided by 4, times my x, plus some unknown y-intercept. If I now try to solve this, I can get that I have 2 is equal to 3 divided by 4 times 2 must be 3 over 2, plus b. I can now go 2 minus 3 over 2 should be equal to b. My y-intercept here should be 1/2, just about, I think. And if we continue to draw this little yellow line in the diagram, such that it continues to go through here, you can see that, hey, maybe I'm not totally wrong. Looks a lot like it might be right. So then the final thing is to simply write all of this information as one final, as one final equation. One final one of these, where you will write y is equal to 3 over 4 times your x plus 1/2. This is thus the equation of a straight line. And that might not be fully visible. Let me just try and lift a little bit so you can better see that part. There, that is the formula. I should say that's not the only way of writing it. It is also possible, since we talked about linear functions, it's also possible to write this with what we call a function notation. Function notation is when you make it look like this. F of x is equal to 3/4 times x plus 1/2. The point of writing it this way is that now, if I later want to talk about the straight line, rather than having to go, oh, I better write this whole thing again, I can just go, yeah, the straight line called f of x. I can just draw that line to it. Saves me a lot of space. Some of the other things that are useful about it is I can now go, well, if I'm interested in, for example, the point 3, I can just put 3 in on x's place, and then I will mean do this function, replacing the x with 3, and tell me what you get. I'm not going to do it with 3. I'm going to do it with 4, I think. So instead, then I would get 3 plus a half. And in other words, I would end up with something like 3.5. That's kind of the power of this. One of the other reasons we're interested in using functions is because functions appear all over the place in mathematics, so you need to be somewhat familiar with this notation. Later, we'll also be looking into the idea of f of x equals to something and then solving for x. That's kind of the power of this, and that's kind of the utility of it. With that, that covers just about everything you really need to know about linear functions, except for a few things that I'm saving for later.